about the topic. What are the topics to discuss? Sources and utilities of water.
Water collection.
How many classification of parameters is there? What are they? What are physical parameters?
Color, order, stability,
Order, stability, and linear. Chemical parameters? Okay. Biological parameter? Now, we discussed about color, order, temperature, TDS, pH, etc. COD and BOD. Now we are going to see about hardness. The hardness can be, there are two main kinds of hardness. First one, temporary hardness. Second one, permanent hardness. Temporary hardness can be removed by boiling the water, and permanent hardness are removed by zeolite process or adding soda lime. And temporary hardness are recommendation by hardness can be recommended by two steps. First one, add with soap, give precipitate with PDTA and DPT, give white red color. See, all the carbonate and bicarbonate are responsible for temporary hardness. Chloride, sulfates are responsible for permanent hardness. See, what is hardness? It is, if you taking the water, if you drink it, it should be having not yet present for the taste water. That kind of water is called hard water. Okay, so that means plain fish water or salty water in the normal standard. Okay, if hardness, this hardness can be classified into two different types. Because of so many minerals are contaminated into the water, the hot water becomes the hardest one. Normally, the hot water having the ppm less than 500 ppm. According to the World Health Organization, the prescribed hardness of the water within the limit of less than 500 ppm. There are two main kinds of the hardness. First one, temporary hardness. There are two main salts are responsible for temporary hardness. Carbonate, CO3 minus, carbonate and bicarbonate. That are the salts are responsible for temporary hardness. Calcium carbonate, magnesium carbonate, magnesium bicarbonate, calcium bicarbonate. Okay, zinc bicarbonate. That are the salts are both carbonate and bicarbonate are the salts are responsible for temporary hardness. There are two kinds of hardness. First one temporary hardness, second one is permanent hardness. So carbonate and bicarbonate salts are responsible for temporary hardness, and sulfates and chlorides, that salts are responsible for permanent hardness. Say some of the salts: calcium chloride, magnesium chloride, calcium sulfate, magnesium water. EDTA, EBP add பண்ணி white color வரலனா that what is that soft water. அதே white color வந்துச்சுனா என்ன color? அது என்ன water? Hot water. That's it. Okay, what is hardness? Excess amount of minerals are present in the water are responsible for the hardness. Okay, there are two main kinds of hardness. First one, temporary hardness. All the carbonates and bicarbonate ions are responsible for the temporary hardness. All the chlorides and sulfate ions are responsible for the permanent hardness. The temporary hardness are removed by boiling the water. The permanent hardness are removed by two process. First one, zeolite process. Second one is the soda. Soda and adding the soda into the hot water. Give the white biscuit. Next one, the hot water can be determined by the two methods. When we taking the water and adding it to the solution. So immediately we get the precipitate that water is called hot water. Second one is the EDTA method. In this EDTA method, EDTA is taken in a beaker. You should be right for it. So the slowly addition. Okay, EDTA is taken in a beaker and hot water is taken in a what is that? EDTA is taken in a burette and hot water is taken in a beaker. We can add in the indicator that is called EBT. EBT means yellow black tea. EBT as an indicator. We get the blue in color. This color will be present. This sandy color will be present. This blue color is turned into the wine red color. Okay, so if we get the wine red color, what is the presence of water? Itself. 21st. What is the meaning of alkaline? Alkaline means that is base. Okay, if the pH scale 7 is the neutral, above the 7 that is called base, that is called alkaline, below the 7 that is called acid. Already we know that. If the water having this presence of these three kinds of salt, that water is called alkaline water. What is the pH range for this water? எவ்வளவு மேல இருக்கு? 6. மூணு சால்ட் இருக்கு. ஹைட்ராக்சைடு சால்ட் or carbonate or bicarbonate is there. அப்ப என்னவா இருக்கலாம்? எவ்வளவு மேல இருக்கு? pH, what is the pH range for alkaline water? More than 7. That's it. So there are three main kinds of alkalinity. C, that is the strongest alkaline. Both we are the weakest alkaline. Here we are using the two different kinds of indicators for that. That is very most important question. This will be already in lab 4. Alkaline is one of the experiment for you. Okay, see, for OH minus is present, we use phenolphthalein as the indicator. Methyl orange is the indicator. So here we use two different kinds of indicator. First one is the phenolphthalein, second one is the methyl orange. OH minus is the strong base. So we are using phenolphthalein as the indicator. CO3 minus 2 minus carbonate and bicarbonate as the weak base. Therefore we are using the methyl orange indicator. See, here we are taking HCl as a urate and taking the conical flask. In this conical flask we have taken 20 ml of the alkaline water. In this alkaline water, 1 or 2 drops of phenolphthalein is added immediately we can get the purple in color. So taking the water, normal water. What is the color of the water? Colorless. Okay. When we add 2 or more drop of phenolphthalein, immediately we get the which color? Purple in color. Purple color, water money color, we get it. And the water color update down I know. Okay, after that that is alkaline water. And என்ன இருக்கலாம்? OH minus இருக்கலாம், CO3 minus இருக்கலாம், or bicarbonate இருக்கலாம். Maybe. Okay, so if you take in that titrated again that HCl. So here எடுத்துக்கிறோம். First water 20 ml depend பண்ணி எடுத்துக்கிறோம் alkaline water. Adding the phenolphthalein as indicator and titrated against HCl. Phenolphthalein add பண்ணனே which color will indicate? Purple in color. Say louder. Purple color. Because this experiment comes for your lab also. That's why I need to explain you. Okay, taking the 20 ml of the water, adding the phenolphthalein as the indicator, we get the purple in color. Immediately we get the purple in color. This phenolphthalein indicator and water sample is titrated against the HCl or taken as a burette. Okay, so after 10 to 15 ml, it will be disappear. Purple in color will disappear. We get the again colorless. That means what? All the OH minus ion are reacted with HCl. All OH minus ion removed by HCl. HCl add பண்ண என்ன ஆகும்? OH minus ion concentration will be diminished. குறைஞ்சிட்டே இருக்கும். அப்ப எல்லா OH minus ion என்ன ஆயிடுவாங்க? React ஆயிடும். There is no OH minus ion present there. Neutralize ஆயிடுச்சுன்னு அர்த்தம். Okay, so we get the colorless liquid. அதுல என்ன செய்யக்கூடாது? We don't fill the burette and don't throw the water, this sample water. Again we add methyl orange here. Again we add same sample la kottame elichidrom. We can add in the methyl orange. We get the yellow in color. We get the yellow. Why we adding the methyl orange? Because we want to find the carbonate and bicarbonate alkaline ion present in it. என்னன்னா find out பண்ணிருக்கோம். We find out only the OH minus ion. The remaining two alkaline ion not to be find. That's why we adding the methyl orange. So methyl orange after adding the methyl orange, the color is turned into yellow in color. It is titrated against HCl. Don't fill the burette. So titrated against the HCl. We get the color is turned into reddish brown color. It indicates the presence of both bicarbonate or carbonate ion. Both la edha ullada carbonate or bicarbonate ion present in the water. Note the end point and put the calculation. That's it. There are two end point. First end point is which color to which color? Purple color to colorless. That is end point of OH minus. Second end point என்ன ஆட் பண்றோம்? adding the methyl orange. என்ன கலர் வரும்? yellow in color. Yellow to reddish orange. Okay, அப்ப என்ன இதோட end point இருக்கும்? carbonate இருக்கலாம் or bicarbonate. Whether it is carbonate or bicarbonate. Okay, so that is called okay. Okay, fast. And this is the water quality parameter over. Sources and impurities and water quality parameter both are over. areas. Okay, தெரியலையா? யாருல இருக்கு தெரியலையா? சரி நெக்ஸ்ட் பண்ணுங்க. So there are four main types of sources. The water obtained from the sources are direct. There are totally what is that? 1, 2, 3, 4, 5, 6 main stages of municipal water treatment. Before first two, screening and aeration is the primary treatment. Sedimentation and coagulation is the secondary treatment. Filtration and sterilization is the tertiary treatment. So the municipal water treatment are treated by three main stages. First one primary treatment. There are two main methods is followed here. First one screening. Second one is the filtration. சொன்னது எல்லாமே paragraph போடுது. Okay. So municipal water treatment are carried out by the three main stages. First one primary treatment. Second one secondary treatment. Third one is the tertiary treatment. In primary treatment, there are two main processes will be followed. First one screening. Second one aeration. In secondary treatment, sedimentation and coagulation should be followed. Third one filtration or sterilization or disinfection. Sterilization or disinfection will be followed. Okay. See what is screening? We get the municipal water. We get the water from the various sources. This water may be having a lot of what is the floating material itself. Maybe the polythene cover or plastic cans, plastic bags or cloth, whether it is a lot of what is that floating material itself. This all the floating materials are completely removed by the screening process. The screening process is essential for removing all the floating materials in the water. Next one, this water are subjected to the aeration. What is aeration? Aeration is nothing but the air mixed with water, that is called aeration. The process of air mixing with water, that process is called what is that? Aeration. In this process, we can remove CO2, H2S, that kind of harmful gases. Not only that, minerals like manganese, ferrous, that is the color producing minerals. These minerals also we can remove from this process. First process is the screening process. Which kind of material we can remove that? Floating material. Second process is the aeration. What is aeration? The air mixed with water, that is called aeration. What we are doing here? Carbon dioxide, H2S, hydrogen sulfide, CO2, H2S. That kind of gases will be removed here. And color producing minerals like manganese, Mn means manganese, Fe means ferrous. Manganese, ferrous also removed here. Okay, color producing minerals also removed here. Next one, the water is subjected to the sedimentation process. The water is allowed to stand for sedimentation tank nearly 6 to 10 hours. The water is allowed to stand on sedimentation tank. That is one of the tank, big size tank. Okay, we have to allow to without having any disturbance, allowed to stand on water nearly 6 to 10 hours. After 10 hours, all the suspended impurities, how many types of impurities we know? These are the impurities. Recall once again. Suspended impurities, colloidal impurities, microorganisms. There are four main types of impurities. In this elimination process, we can remove the suspended impurities, especially for suspended impurities. So without having any disturbance, all the suspended impurities are settling down. So we can be easily removed by the filtration method. Okay, the procedure will be just only removed by the what is that? Floating process or water some other process. Okay. See next one, the water again sending to the coagulation tank. What is coagulation? Coagulation means that is the process removing all the colloidal impurities. What is colloidal impurity? What is colloidal particle? The particle having the size 10 power minus 4 is called 4 meter. The particle having the size 10 power minus 4 meter, that particle is called colloidal particle. So in coagulation process, we can remove which kind of impurity? Colloidal impurities. So how can we remove? Taking the water and add it to the alum. What is alum? Aluminum sulfate is the chemical name for the alum. We convert it into aluminum hydroxide. That is the white color gelatinous precipitate. If you taking the water and adding the alum, alum means alcohol. Okay, adding alum. The chemical name of alum is aluminum sulfate, potash alum. That means potassium aluminum sulfate. That aluminum sulfate is converted into aluminum hydroxide. Aluminum hydroxide look like a coated piece like structures settle down. That is a white color gelatinous precipitate. Okay, we can remove by the what is that? The filtration method or blow down process. Okay, so all the what we taking after the water enter into the colloidal coagulation tank, we can add in a small amount of potash alum fluids. Okay, potash alum means aluminum sulfate. That is called alum. That is called alum. What is the chemical formula for alum? Aluminum sulfate. Potash alum means potash munnadi potukanga K K2 KAL S443. That's all. Alum na aluminum sulfate. That's all. Okay. So water is added into the aluminum sulfate and it is converted into aluminum hydroxide. The aluminum hydroxide is the white color gelatinous precipitate. Should be settled down. It can be removed by the blow down or filtration process. The process is called coagulation. What is coagulation? Coagulation is the process of removing colloidal impurities. Say once again yourself. Okay. Colloidal. What is coagulation? Coagulation is the process of removing colloidal impurities. What is colloidal impurities? The particle having the size 10⁻⁴ meter. That is called colloidal impurities. Okay. That what we are doing. So what is added with the alum? Alum means aluminum sulfate. That aluminum sulfate is converted into aluminum hydroxide. The aluminum hydroxide is the white color gelatinous precipitate. It can be removed by the filtration process. The whole process is called coagulation. Next one, filtration. We already know that maximum of the water having a blue color RO tank. RO, what is that? Green, one of the tank is fitted there. So it should be consist of various layers itself. That is called fine sand, sea. One of the RO tank having some of that kind of what is the green layers itself. First one fine sand, second one thick sand, third one fine gravels. Fine gravels, third one thick gravels, charcoal and some more chemicals also itself. Okay, when the water is sent into the filtration tank, when the water is after completing all the process screening, aeration, sedimentation, coagulation, after completing all the process, the water is sent into the filtration tank. The filtration tank itself having the various beds itself or various layers itself. What are the layers of the fine sand, thick sand, fine gravels, thick gravels, and activated charcoal. That is the basic filtration tank layers. Okay, when the water is allowed to stand pass through the various layers, all the imbalanced suspended, colloidal, dissolved impurities are completely removed. We get the 90% of the purest form of water. Okay, so last one, the water is sending to the sterilization tank. First layers of the municipal water we are getting from the various sources. What is that? Sending to the various process. First one is there are three main processes we have followed. First one is the what is that? Primary treatment, secondary treatment, and tertiary treatment. Screening and aeration is the primary treatment. Sedimentation and coagulation is the secondary treatment. Next one, filtration and sterilization and disinfection is the tertiary treatment. The water is allowed to pass through the screening. What happened here? It is a process of removing all the floating materials. After that, the water is allowed to pass on the aeration tank. What is aeration? Aeration. In this process, we have removed all the offensive water gas we can remove all the suspended impurities. The water is allowed to stand for 6 to 10 hours. After 10 hours, all the suspended impurities are settling down. So we can easily filtrate, take the filtrate of the purest form of water. The precipitate is removed by the blow-down process. Okay, or filtration process. Next one, after completing the sedimentation, we send the water into the coagulation tank. In coagulation is the process of removing colloidal impurities. Colloidal impurities means the particle having the size 10 power minus 4 is called colloidal impurities. So we can add iron to the water. The iron is nothing but the aluminum sulfate. It is converted into aluminum hydroxide. Aluminum hydroxide is a white but gelatinous precipitate. It should be settled down. We can remove by the filtration process. After the water is released to the filtration tank. The filtration tank having the various values itself. First one, fine sand. Second one, thick sand, fine gravels, thick gravels, activated charcoal. There is the basic layers of the present in the filtration tank. The water is allowed to pass through it. We get the 90% of the purest form of water. After that, finally the water is released to the sterilization tank. Write it fast. See, sterilization or disinfection is the process of removing harmful bacteria. In this process, we have followed the four main techniques. First one, boiling the water. Boiling the water should be to kill all the harmful bacteria. But the main disadvantage of this water is it is not applicable for the large storage water, especially for the municipal water treatment. Because we can able to boil in the enough amount of water. There is no infrastructure for us. Okay, so that is ruled out for the municipal water treatment. But it is also one of the process of removing harmful bacteria. Next one, ozonation. By adding ozone into the water, the ozone is split up into the oxygen plus O dot radical. That is called oxygen dot radical. O dot radical. Okay, that oxygen dot radical is a best disinfectant. Disinfectant and bacteria கொல்லக்கூடிய ஒரு மருந்துகள் பூச்சிக்கொல்லி மருந்து react ஆகும். Disinfectant means பூச்சிக்கொல்லி மருந்து. ஓகேவா? The oxygen dot radical acts as a best disinfectant. So it will kill all the harmful bacteria, but it is very costly. The main disadvantages of this process is it is very costly. Next one, by passing the UV radiation into the water to producing current through the mercury vapor lamp, we have adding the UV radiation into the water. The UV radiation kills all the harmful bacteria. This methodology mainly useful for the swimming pool. Swimming pool la indha vacha panniyana seiraanga bacteria se poduvaanga. See, next one, chlorination. That is very common method we are following for all the sectors. There are three main types for following the chlorination. First one, direct addition of the chlorine gas. Direct addition of the chlorine gas remove the harmful bacteria. Second one, addition of chloramine. What is the meaning of chloramine? That is a combination of ammonia and also chlorine. What is the formula for ammonia? NH3. It is added to chlorine. Okay, one of the hydrogen from ammonia, one of the chlorine from chlorine. We get NH2Cl plus HCl. இங்க இருக்கிற ஒரு ஹெச்சும் இங்க இருக்கிற ஒரு சியும் HCl ரிமூவ் ஆயிடும். கவனி, அம்மோனியால இருக்கிற ஒரு ஹெச்சும் குளோரின்ல இருக்கிற ஒரு குளோரினும் HCl ரிமூவ் ஆயிடும். ரிமைனிங் இருக்கிற NH2Cl கம்பைன் ஆனா அந்த காம்பவுண்ட் பேர் என்ன? chloramine. The compound is called chloramine. One of the hydrogen from ammonia. What is the formula for ammonia? NH3. What is the formula for chlorine gas? Cl2. Cl2. Cl means chloride. Yes, that's true. Cl na chloride. Cl2 means chlorine. Okay. So ammonia is reacted with chlorine gas. Cl2 ammonia is reacted with chlorine. Ammonia is reacted with chlorine gas. So one of the hydrogen from ammonia, one of the chlorine gas also removed by HCl. We get the chloramine. The chloramine acts as a best disinfectant kill the harmful bacteria. Next one, see bleaching powder. What is the formula for bleaching powder? That is called calcium oxychloride. That is the chemical formula for bleaching powder. Calcium calcium oxychloride. That is the chemical formula for bleaching powder. So when we add the bleaching powder into the water, the bleaching powder is converted into the calcium hydroxide, CaOH twice. The bleaching powder is converted into the calcium hydroxide. The calcium hydroxide is reacted with the chlorine present in the calcium oxychloride. We get HOCl. That is called hydrogen oxychloride. Hydrogen oxy வேற வச்சு படிக்கணும். Hydrogen oxychloride. Say hydrogen oxychloride. HOCl. The HOCl, the hydrogen oxychloride is a best disinfectant to kill the harmful bacteria. What is the formula for bleaching powder? CaOH. Calcium. What is the name also? Calcium oxychloride. What will be done here? Calcium oxychloride is reacted with water, converted into calcium hydroxide. This calcium hydroxide again reacted with chlorine gas. when we adding chlorine after the water, which kind of reactions will be occurs there? It will be represented by the graphical representation. That is called breakpoint chlorination. When we adding the direct addition of chlorine or chloramine or what is that? Bleaching powder into the water. First, initially, the chlorine kill all the harmful bacteria and oxidation of the reduced compound present in the water. That is the first segment. After that, what happened? That is the applied chlorine. That is the residual chlorine. Applied chlorine means we apply a certain amount of chlorine into the water. That is called applied chlorine. Residual chlorine means after killing the harmful bacteria, the remaining chlorine are settled down. That is called residual chlorine. When the applied chlorine increases, see, when that is the graph. When the applied chlorine increases, residual chlorine also increases. See, that is gap. Okay, peak is the represent the residual chlorine also increases because the formation of chloramine and chlorocompound. Yeah, applied chlorine increase or the residual chlorine also increase over there. Formation of chloramine and chlorocompound. See, when the applied chlorine increases, here the value increases, the white value increases. But residual chlorine is not there. That is called residual chlorine. See, that can get out. So, when the applied chlorine increases, residual chlorine decreases. That is the third segment. Because destruction of chloramine and chlorocompound. So, at the minimal point is called breakpoint chlorination. This point is called breakpoint chlorination. In this point, the combined residual chlorine is very low in amount. After that, we get the free residual chlorine. So, that is a graphical representation of breakpoint chlorination. The breakpoint chlorination is nothing but it is a graphical representation between the applied chlorine and residual chlorine. It is separated by the four main segments. First segment, when we adding the chlorine, it kills all the harmful bacteria and also oxidation of the reducing compound present in the water. Yadala by chlorine. That is the first segment. Second one, after completing this all the reaction, what happened? The applied chlorine increases. Dicyclic increases. Increases. Okay, the applied chlorine increases. Combined residual chlorine also increases because the formation of chloramine and chlorocompound. The applied chlorine increases, but the residual chlorine decreases because destruction of chloramine and chlorocompounds. At the minimal point is the breakpoint chlorination. In this point, we get the low amount of residual chlorine. After that, we get the free residual chlorine. That's it. Residual chlorine means after the reaction, we get the certain amount of chlorine is deposited here. That is called residual chlorine. Applied chlorine means if we get 5 grams of chlorine is applied into the water. So how many amount of chlorine applied into the water is called applied chlorine. You understand? If you have any doubt, we will discuss in the next class.